All right, so this video is for Ionic nomenclature practice number 2. So basically kind of doing the same stuff we did for the last one, but now we're dealing with transition metals. So remember, transition metals are going to be back in this group on your periodic table. So transition metals start at group 3B, so just going after group 2A, and it's going to go all the way to your staircase. Okay, remember the only ones that are exempt from basically having any charge would be silver, which is always a +1. Zinc is always a +2, and aluminum is always a +3. Okay, then you have your other groups. You have group 8 is 0 charge, then -1, -2, -3, ±4, +3, +2, and +1. So hopefully you're starting to see that when I'm talking about these charges, it gets really repetitive because we will use this throughout the rest of the year. And it never fails that I have a lot of students that just keep forgetting what the charges are. Okay, so it always is 0, -1, -2, -3, ±4, +3, +2, +1. And then your transition metals are in the middle. Okay, that means that they can basically be anything. So that's why we're going to use those Roman numerals here in a second. And then silver, zinc, and aluminum are always +1, +2, +3. And they do not need Roman numerals. Okay, so we're going to start off. We're going to basically doing the same thing as we're basically writing out the pieces, the cation and the anion, the formula once you bring those together, and then the chemical name. So if I look at my first example, I have Fe3+ and then Cl1-. So I can see that those are not balanced. So you can do your crisscross method. So take the 1 from the chlorine over here to the iron and take the 3 from the iron all the way over here to the chlorine. So that means my correct formula, my balanced formula would be FeCl3. Okay, now when we get to our names one of my first things is when I get to a name, I always check, is this a transition metal? Is it in anything from 3B over to the staircase? Okay, so remember, groups 1 and 2, so this giant section right here, groups 1 and 2, okay, do not need a Roman numeral because they're always the same, +1, +2, and then silver, zinc, and aluminum in the transition metal group does not need a Roman numeral as well. Okay, so remember, if those charges never change, you don't need to tell me the charge of it because we know it. So in this case, iron is a transition metal because if you look up here, iron is right here, smack dab in the kind of middle. So that means you have to tell me the charge of iron in the name. So you're going to write iron. And you're going to look right back here. Iron has a charge of +3, so you're going to write iron 3. And then chlorine still becomes chloride. So again, if you need to know your Roman numerals again, so if you need to know 1 is I, and then 2 is II, and then 3 is III. 4 is, remember, that's the IV because I becomes before the V. Then you have V is 5, and then VI is 6, and then VII is 7. That's basically all you need to know. Now the next example, I have FeCl2. Okay, so again, when you use your transition metals, always take a look at your anion first to determine what it is. Okay, so if I look up chlorine on the periodic table, I know chlorine is always going to have a charge of -1. Because if you look up here, chlorine's right here, it's always going to have a charge of -1. So you can go ahead and put your anions down. Okay, so pretty much for this entire worksheet, you can fill out your anion sheet first. Okay, your anion section first because those are never going to change. So if I have chlorine with a -1 charge and I have 2 of them, that means my total charge for chlorine is a -2. Okay, and if I only have 1 iron to balance that out, that means it has to have a charge of +2. So this would be Fe with a +2 charge. Now you can do reverse crisscross method. Okay, so if you took the 2 up to the iron here, and then you took the 1 up here to the chlorine, that would technically be correct because chlorine has a charge of -1 and iron has a charge of +2. Okay, I like to look at it visually. I can just look at them and balance them out, basically just trying to get the same number. Now I know my charge of iron, so I'm going to write out iron 2, and this still is chloride. Okay, so one thing I do want to point out here is I'm going to erase this real quick, kind of clear that up, is if you look at this 2 right here, that does not tell me that I have 2 irons because if you look over here, I only have 1. Okay, that is another big mistake we see is everyone thinks that Roman numeral is telling you how many irons there are. It is not. It just tells you the charge of the iron by itself. Okay, it does not tell me how many there is, so don't make that mistake. Okay, so let's look at this next problem. So one of the common problems I would see is I would see something like this. Someone would write Cu2Br. Okay, because they see that 2 right here, they think there are 2 coppers. That is not the case. Okay, so I'm going to go ahead and erase that because that one's wrong. Okay, so now what that does tell me is that copper has a charge of +2. So you can go over here and write in your cation box, you can write Cu with a +2. So there's your first answer. And then bromide is bromine. So you're going to look up bromine on your periodic table. That is Br with a -1. Okay, so now I'm going to make sure, are they balanced? I can see that they are not. So you can do your crisscross. So that only means I need 1 copper and 2 bromines to be considered balanced. Now, my next one is Cu2O. Okay, so if I look up oxygen on my periodic table, so I'm going to go ahead and write O over here. O has a charge of -2. Okay, so that means my total charge for oxygen is going to be a -2. That means my total charge for copper has to be a +2. Now, since I have a total charge of +2 and I have 2 coppers, I'm going to take that 2 and divide it by 2, which is going to mean each one has a charge of +1. I'm sorry, that's a +1, not a +2. Okay, so that's one method that I like to do is I just simply look at what the total would be and then divide it by however many I have. Okay, now you can do the reverse crisscross method, so let me clear this up and I'll show you that. Okay, so if I take this 2 up here to oxygen, that means it's a -2. Then I would have to check my periodic table. Does oxygen has a charge of -2? It does. So that means the reverse crisscross method would work, and this is not a reduced formula. So that means if I only have 1 oxygen, I would take that 1 up here to copper, and that means copper has a +1 charge. Now I'm going to come over here to my name, so I'm going to write out copper. Okay, and I'm going to write the charge of this copper, which would be 1, so you're just going to write I, and then oxygen becomes oxide. Okay, let's look at the next one. I have Pb2+ and S with a -2. I can see that those are already balanced. All I got to do is put those together, so PbS. And then my name is going to be, so Pb is lead, and then the charge of my lead is a 2, so it's a +2. And then sulfur becomes sulfide. Okay, then I have Pb +4 and P -3. I can see that those are not balanced out, so you can crisscross. So you can write P, I'm going to take the 3 from phosphorus, so that means I need 3 leads. So I took the 3 over to here. I'm going to take the 4 over to here, so that means I need 4 phosphoruses. Okay, so there's my formula. Now I'm going to write my actual name. Okay, so I'm going to write lead. And again, remember to take the charge, not how many. So lead has a charge of 4, so that's going to be IV. And then phosphorus becomes phosphide. Okay, what I'm going to do now is I'm going to jump down here. I'm going to do this Ag3N one right here. The reason why I want to do this one is because it deals with the name. Okay, remember those 3 that are always going to be the same. Okay, so silver, if you look up on the periodic table, is always going to be a +1. So I can go ahead and write Ag +1. Oops. Okay, then I can look up nitrogen on the periodic table. Nitrogen is right here. That's in group 5A, so that means there's a charge of -3. So I'm going to write N with a -3. Okay, so I can check to see if the reverse crisscross method would have worked. Okay, so if I have 1 nitrogen here, I would take that up here. Let me clean that up a little bit. If I have 1 nitrogen, I would take it up here, meaning the charge of silver is +1, and then 3 from silver is going to go up here. That means there's a charge of -3. So that would work. Now, when it gets to naming, okay, remember silver is one of my 3 that is always the same. So that means all I have to do is write silver nitride. There is no Roman numeral for silver. Okay, the same would be for zinc right here. Okay, zinc is also one of my 3 that's always the same, so it means I don't have to write the Roman numeral in the name. So my name would be zinc bromide. Now, again, if it's anything besides, in that transition group, if it's anything besides silver, zinc, and aluminum, then you would have to write a Roman numeral. So just watch out for that, as you do not have to write a Roman numeral for those three. Now we're going to flip to the back side. So we want to write out the ions and chemical formulas. So we're going to write out the pieces and then put them together. So manganese is actually M. So remember, watch out for manganese and magnesium. Manganese is Mn, and that VII is the same as a 7. So that's going to be manganese with a +7 charge. And then sulfur, if you want to come back up here to the periodic table. So again, manganese is right here, so number 25, and then sulfur is right here, and that's going to have a charge of -2. So I can see that those are not balanced, so you can just crisscross. So that means this is going to be Mn2S7. Okay, so there's my ion, so there's my cation, there's my anion, and there is my formula. Okay, tin for bromide. So tin is Sn, the abbreviation is Sn, and that's going to be a +4 charge. Bromine is Br with a -1 charge, so that is not balanced. So you're going to go ahead and crisscross those. So that means I only need 1 tin, so Sn, and I need 4 bromines. So there's my formula. Sn +4 is my cation, and then bromine with a -1 is my anion. All right, titanium 3 nitride. Okay, so we come up here. Okay, so if you need help finding titanium, so titanium is right here, number 22. Okay, so if you ever have trouble finding something on the periodic table, don't hesitate to ask. Okay, so titanium is going to be Ti, and that's going to, that 3 right there gives me a +3. And then nitrogen is going to give me a -3. Okay, so I can see that those are already balanced out. So this would just simply be TiN. So there's my formula, and then there's my cation and my anion. Okay, let's go down to the next section. Is I'm simply going to name them. Okay, so that means I really do, on this one, you just can't simply write out the name just by looking at it, because you really need to be able to find the charge, because when you're dealing with a transition metal, you need that Roman numeral. So if it is a transition metal, we need to find the charge of it. So I have CuF. Okay, so Cu is copper. That is one of my transition metals. So let me come up here to my periodic table. So let me clean this up. Okay, we're still going to keep that silver as plus, oops, let me switch over to my pen. +1, +2, +3. Okay, so copper is right here. That is one of my transition metals. And then F is right here, and that is a charge of -1. Okay, so if fluorine has a charge of -1 and only have 1 copper to balance it out, that means it's going to have a charge of +1 in order to be balanced. So my name would be copper 1, so you got to put that in parentheses, fluoride. Number 12, Ca3P2. Okay, so if you look on your periodic table, so Ca is not one of my transition metals, it's in group 2. So that means I don't need a Roman numeral, meaning I don't need to know the charge. So I can just simply write calcium, and then phosphorus becomes phosphide. Okay, Cr2O3, so chromium, Cr is one of my transition metals. So that means I need to find the charge of it. Okay, so I'm going to try this reverse crisscross. So I'm going to see if I can take the 2 up to oxygen, and that makes it a -2. Then you would check your periodic tables. Does oxygen have a -2? It does. So therefore, I can just reverse crisscross this 3 up here to the top of chromium. So I give you a +3. So that means my name would be chromium 3 oxide. Okay, so hopefully that kind of clarified things as far as transition metals and using Roman numerals, and when and not use Roman numerals. And then the next video will be going over how to use polyatomics and the naming that goes along with those.